In this lesson, we're going to be looking at linear and angular velocity. Before we can discuss both of those velocity, we need to first understand what angular displacement is. When an object rotates clockwise about a fixed point, which is the center of that rectangular coordinate system, the central angle is known as the angular rotation or angular displacement. So the angular displacement, when something is displaced, it's moved from its original position. So if the terminal side of that angle starts at the initial side, as you rotate it, it's being displaced. That displacement is the angular displacement. So angular velocity is the speed by which that point on the circle is being displaced. So if an object moves along a circle during time t, then the angular velocity, omega, lowercase omega, is the angular displacement divided by time. All right, so omega is the symbol that's used for angular velocity. And to calculate the angular velocity, you divide the angular displacement, theta, by t, time. And then lastly is linear velocity. If you were to take that curved displacement and straighten it out to a straight line, you would have the equivalent linear velocity, which is determined by multiplying the radius of that circle by the angular velocity. All right, so to find the linear velocity, you're going to multiply the radius of that circle by the angular velocity, omega. All right, so example 1, we want to determine the angular displacement, theta. All right, so if we have 5.8 revolutions, each revolution being 2 pi, we just multiply 5.8 by 2 pi, and it would be exactly 11.6 pi. If we were going to round our answer, it would be approximately 36.4 radian. So again, the exact displacement would be 11.6 pi radian. The approximate displacement would be 36.4 radian. And if we wanted to determine the angular displacement for 710 revolutions, again, each revolution being 2 pi radian, so we'd multiply 710 by 2 pi, and we would get exactly 1,420 pi radian, or approximately 4,461.1 radian. Now to determine the angular velocity, omega, we're going to first determine what the angular displacement is. So we're going to multiply the 3.2 times 2 pi. So the angular displacement is 3.2 times 2 pi. And then we're going to divide that by the time, 7 seconds. When we multiply the numerator and then divide by the denominator, we get approximately 2.9 radians per second. And for this example, we're told that there are 700 revolutions in 15 minutes. So again, we want to find the angular displacement first by multiplying the number of revolutions by 2 pi and then dividing that by time, 15 minutes. Once we multiply the numerator and then divide by the denominator, we get 293.2 radians per minute. And then for linear velocity, we're going to multiply the radius of the circle by the angular velocity. So we're told that the angular velocity is 36 radian per second. And the radius is 12 inches, so we just simply need to multiply those two. and we get 432 inches per second. That would be the linear velocity. And lastly, given that the angular velocity is 5 pi radian per minute and the radius of the circle is 7 meters, to find the linear velocity, we would just multiply omega by the radius. So 5 pi times 7 is approximately, let's change that to an approximation symbol, approximately 110.0 meters per minute. That would be the linear velocity.